Hello, and welcome to today's web seminar entitled Acting on Real-Time Behavior, How Peak Games Won Transactions. I am Dennis Duckworth, Director of Product Marketing here at VoltDB. I will be your host and one of your presenters today. Joining me from Istanbul, Turkey is Sada Şahin, Head of Cloud and Big Data Services at Peak Games. Sada has extensive experience in the big data space and heads up Peak Games' data and architecture strategy. He graduated from Central Queensland University in Australia with distinction. He has held key engineering positions in the areas of RFID, online publishing, and most extensively in the gaming industry. I'm going to start with some brief comments about data and analytics trends in the marketplace today. I'll turn it over to Sada for a deep dive on Peak Games' use of VoltDB for acting on real-time behavior. I'll come back for a higher level look at VoltDB and touch on some other use cases. And then we will wrap up with answering your questions. Competitive advantage is no longer about being first to market. It's about being first to value. We all see the power that data and analytics is having in completely disrupting markets and even creating brand new markets. Every industry, every business needs new ways to think about data and its value. Early adoption doesn't guarantee success. In a Forrester survey of enterprise architects back in October 2015, they found that only 29% said they're good at translating the results of analytics into measurable business outcomes. Most big data projects only address finding insight in data, not turning insight into action. This probably isn't a surprise to anyone on this call, but most companies strive to improve their customers' experiences. The details for what that means and how it can be done really depend on the industry. For a telco, it might mean calls go through faster or having no dropped calls, or reaching a customer support person who already knows about your dropped calls as soon as they pick up the line, instead of needing you to recite your 40-digit ID number for the third time. In financial services, it may mean better investment options that are presented to you on your phone when you're checking your balance. In gaming, it might mean games that are more engaging and thus more enjoyable for you. And now, Sada, tell us more about the cool things that Peak Games is doing with analytics and user segmentation to improve your customers' experiences.
Thanks so much, Dennis, and thanks to everybody who is watching right now. I'm Sada Şahin, the head of Big Data and Cloud Services at Peak Games. I look forward today to talking about how we use VoltDB because it is at the center of a lot of what we do over here in the Big Data department. As part of this webinar, I want to tell you how and why Peak Games was founded, what is our Big Data vision, where we use VoltDB, and how it powers our internal services. And finally, I want to show you the architecture of the segmentation service in which you can see how VoltDB is being used currently. Peak Games was founded over 5 years ago with the idea of creating a technology company based in Istanbul, Turkey. Since then, we have published many games, some of which have been very successful in their respective markets. For instance, Toy Blast is currently in the top 20 grossing list in the iOS App Store in the United States. Likewise, Space Plus is in the top 100 grossing list in the Android Play Store, again in the United States. We also have many games for the Turkish market, such as 101 Plus, which is the biggest community-based game in Turkey. And it has more than 100,000 concurrent players playing the game at peak times. We started off with social games on Facebook, so mobile was a later step. We only started 3.5 years ago developing games for mobile. And we have gone from there to be one of the leaders in the mobile gaming space. We specialize in multiplayer synchronous board and card games, as well as single-player puzzle games. We are a team of 100 people. We have many games in the mobile app stores, and our users reside in over 150 countries. I can say that we have 300,000 players playing our games at peak times, and so we are happy with the growth that we are having, but we still have a long way to go to reach our vision. So I think that's enough about numbers. Let's move on to the big data services that we provide here at Big Games. As a team, we provide a broad variety of services to assist our gaming studios in developing and promoting the games. We also develop services that enable our user acquisition, analytics, and CRM teams to take meaningful actions depending on the user behavior. So our first responsibility is to make sure that we can collect and process as much data as we can. We enrich the same data and provide it back to the relevant people and departments such as studios and analytics teams, as I mentioned. Apart from the infrastructure, we also develop data-driven self-service products. So with the services we develop, we enable our teams to streamline and automate the processes and actions involved in A/B testing, CRM, and pricing optimization. All of our services are totally independent from code releases and from the games, so they can be easily managed through a centralized UI. One of the first services we have developed is the CRM platform, which is an omni-channel CRM platform where you can send push notifications, Facebook notifications, in-game messages and such. It also allows our CRM team to run A/B tests on the marketing content and perform segmentation without any coding skills and support from the development team. Dynamic pricing is another component of the CRM platform, which enables our studios to adjust the in-app store pricing across all platforms on iOS, Android, and on Facebook. Another service we provide is the A/B testing platform, where you can run A/B tests on the in-game content in a scientific and controlled manner across our games. Once it is implemented for a particular use case, tests can be ran repeatedly and independently from the game. For example, our studios could A/B test a level design by uploading multiple versions of the same level and present them to a sub-segment of the game players and comparing the statistics. We run tests to evaluate the game mechanics, game features, offers, and pricing strategy to find out what gamers value the most. We also use this A/B testing platform to add A/B testing functionality to other services as well. For instance, dynamic pricing component uses this A/B testing system to have A/B testing functionality. And finally, we also provide services to our user acquisition team where they can retarget our churned users on other ad networks such as Facebook, AppLovin, and more. Based on the rules that they come up with, whenever the system detects a churned user, we target the same user on other ad networks using their Facebook ID or advertising identifier for mobile. We also remove them from this retargeting list as soon as they come back to the game, so that we don't target those people who is actively playing the game. Cross-promotion is another case where we started experimenting with. We show different ads for different types of users, though this is a very new feature. Before moving on to the next slide, I must say that all the services that I've been telling you have the ability to segment players based on the rules that our analytics and CRM teams come up with. This is where we use VoltDB. VoltDB powers the segmentation service that these services integrate with. It enables these services to slice and dice the user base and take personalized and real-time actions. Now, I'd like to tell you how and why we needed to develop these services internally. You may think that there are many third-party services that provide the functionality of these services. But the truth is there is no single solution that provides the functionality that our teams require. For instance, there is no CRM tool that we could find which can use web and mobile-based channels like Facebook notification, push notification, as well as provide some API to add custom channels like in-game messaging. Even if we find something similar, it lacks some other functionality like sophisticated segmentation. Likewise, there is no good A/B testing solution for server-side A/B testing. We might just want to test the beginning inventory of a particular game, like how much lives you are going to start with, and this test may need to be targeted to a specific segment of the user base. There is no off-the-shelf product that meets these requirements. Another issue with the third-party services is the historical data. Whenever you use these services, you somehow need to send all of your historical data to populate all of the existing segments on these third-party services. And yes, most of the services have the segmentation capabilities, but they start populating their segments from the moment you implement their service and naturally discard the historical data. And finally, their predefined filters are very generic. Their filters are like the install date or number of purchases the user has made. However, whenever you want to create a custom filter, it is always a problem on these services. Like the example shown in the slide, we have many rules that are custom to a particular game. For instance, you can target users who stuck at their last level, try to pass it n times, and it's still on the same level for the last x days. So when it comes to segmentation service that powers these services, we have a number of requirements to meet, some of which are ability to process historical data, ability to answer both batch and real-time queries, and ability to run arbitrary queries. For instance, we might have 100 properties for a user, like the install date, user location, gender, and so on. We need to be able to combine or exclude any of these rules. It is like adding indexes on every column of a database. When we first started researching how to build the segmentation service, it quickly became apparent that the real-time requirement is the hardest part. The consensus in the team was that it will take so much time that it might delay developing the internal services that we haven't started using yet. We might be developing a wrong product with a wrong vision. So to tackle this problem, we started with the features that don't require real-time actions. There are some potential actions that you can take which don't require real-time data. So we started with a Lucene-based engine. Having previous experience on Lucene was the main reason that we have chosen it. We were aggregating the data in our data warehouse incrementally, and we were loading it onto this engine at regular intervals. There was nothing real-time about that, but it did the job at that time. So thanks to that, we could start using the CRM. As soon as we had something working with the initial implementation, we started exploring stream processing frameworks to see how can we leverage them to add real-time processing capabilities as we had planned initially. We first considered frameworks like Spark and Storm, although they are very good at what they do and have many more capabilities than what we require. Not all requirements could be satisfied only with stream processing frameworks. Spark is a general purpose cluster computing system. It doesn't natively support persistent storage. So we had to persist the data in a relational data store that is scalable, SQL and join supported, and also ACID compliant. Since we would be querying this data store in a transactional manner, we naturally investigated new SQL databases. So this is where we found VoltDB. Potentially, we could use two different solutions, a stream processing framework like Spark and a database, but that meant a lot of glue code, and which would make exactly once processing harder to implement. It would be operationally difficult to maintain both services and also guarantee exactly once semantics. So in light of this information, we focused on VoltDB and started exploring its features. VoltDB is a good designed database that can meet stream processing requirements. But even if you leave the stream processing capabilities out of the picture, you still have an ACID compliant scale-out relational database which supports SQL with joins. It even has JSON support, which we are using, and all these features are not easy to come by in a scale-out database. Also, since you store the data where you process it, it makes exactly once semantics easier to implement. Not only the database is ACID compliant, it makes your stream processing activities also ACID compliant. To be honest, one of the other reasons we have chosen VoltDB is Michael Stonebreaker, who is the force behind many known databases like Vertica and PostgreSQL. So that's another reason. After choosing VoltDB, we started implementing it to our segmentation service. Our segmentation service is a service in itself, which you can plug into any product that needs personalization. If we are developing a new service that requires personalization, this is the centralized service that can do that. It is a rule-based system. I will show you some screenshots after a couple of slides. You can combine filters and create new rules, which will then be translated into SQL queries. It is basically a SQL generator. One of the strengths of this architecture is that it replicates the same data model on our data warehouse. It allows us to execute max campaigns on the same data model using batch queries. I will give you some examples shortly. So our segmentation service can answer two types of distinct queries. One of them comes from the games themselves in a transactional manner. When you open the game, either the client or server asks one of the services like CRM or A/B testing to see if there are any active campaigns we are running for a segment that the user belongs to. This has O1 complexity in technical terms. This is a real-time transactional query for a particular user. It is like asking if there is an offer for a particular user or if there is any split test running for this user and so on. The other type of queries comes from the CRM application itself. So our CRM team might want to send mass push notifications to announce a new update for a game or for an event like Christmas. And this query gets generated in the same segmentation service. The difference is we now need to find out everyone who belongs to a specific segment, which can have millions of users. This is not a good query type for transactional databases, generally speaking. So mass campaigns don't have real-time requirements, meaning that you can't send millions of push notifications in 3 minutes. It takes time to reach all of the users, so it doesn't matter whether your data is late by 3 or 5 minutes. For that reason, we can use another database, even if the data is late by a couple of minutes, to process this complex query, which has O(n) complexity in technical terms. So we use export on the tables in VoltDB to get the same data to our data warehouse. So we do cross-database replication in that sense. And our data on our data warehouse is generally late by 3 or 5 minutes at maximum when comparing to VoltDB. Here you see our segment editor. The UI and its JavaScript components come from an open source project. We use this UI, and the service generates a SQL query behind it. So let's start with an example. In this particular screenshot, we choose countries. We can then add as many rules as we like. As you see here, there are 2 more rules for the same segment. In the first screenshot shown above, we select users who stuck at their last level for the last 5 to 15 days. In the second screenshot, we have the users level. And finally, you see the final rule here, which has combination of all the filters that we have chosen previously. This particular example has 3 properties, but you can add as many rules as you like. You can formulate the rules by combining them or excluding from each other, as you see in the editor. Here you see the architecture of the segmentation service. Everything starts from Kinesis, as you see in the top right corner. We use Kinesis as our message queue. Kinesis is a publish subscribe messaging system, which is provided as a service by Amazon Web Services, and it compares to Kafka in terms of functionality. If you know Kafka, Kinesis is very similar to that, although it has a subset of features of what Kafka can provide. So we consolidate all of our user data in Kinesis and partition it by the user ID on Kinesis. By doing that, we preserve the ordering of the messages coming from the same user. Events come in many formats, in many sources, from many sources. Most of them come from our own API, which collects behavioral data of users. Another source is the database of the game. We continuously replicate MySQL databases to Kinesis using its binary protocol. We also have some third-party sources, but they are not used in this part of the architecture. After consolidating all the events generated by users in Kinesis, we forward them to VoltDB. Our Kinesis consumer is a simple consumer, which has the responsibility of forwarding the right events to the right stored procedure in the right order. It has some other functionality for initial data loading on VoltDB, but I'll come to this later. As you see, there is another component of the architecture, which is represented as MPP database. We use a columnar database, a massively parallel processing database. Although it is not clear in this diagram, there is bidirectional communication between our data warehouse and VoltDB. As I mentioned earlier, we use VoltDB's export-only tables to replicate the same data with the same data model. This allows us to execute large batch queries on our data warehouse using the same enriched and highly compact data. If we are going to run, say, a Christmas campaign for millions of users in a batch fashion, the user data for that segment comes from this data warehouse. You might also think that why do we need to replicate the VoltDB's data anyway? So the data in Kinesis is already in our data warehouse, which is consumed by another Kinesis consumer. But the thing is, the raw data on our data warehouse is verbose and mostly append only. So if we would be aggregating the raw data on the fly on our data warehouse, it would take so much time. So it would also need to be a large SQL query, and it cannot be generated on the fly easily. On the other hand, when we replicate the same data model, it allows us to execute almost the same SQL query, SQL query that is generated in this segment editor. Also, the replicated data on data warehouse is quite fresh, although not real time. It is generally late by 3 minutes. It's generally 3 minutes behind VoltDB, and it's perfectly acceptable for batch campaigns. We cannot send millions of push notifications in 3 minutes anyway, so it doesn't need to be real time for our use case. So as I said earlier, there is bi-directional communication between VoltDB and our data warehouse. So there is another role for our data warehouse in this architecture. Some of the user data is pushed from data warehouse to VoltDB at regular intervals. These are generally computationally expensive calculations, and they don't need to be real time. If I give an example, for instance, we regularly calculate the most active time of the day for every device that the user uses based on the last 3 months of activity. So, for example, you might be using your desktop in the morning, your Android phone in the evening, and your iPad during the night. When we are doing batch campaigns, we sometimes use this data to deliver notifications when the user is most active during the day. So this is how all these systems work together. I hope everything was clear for you. So when it comes to our data model, this is a very basic representation of our data model in VoltDB. Just to give an idea for you. Every event is processed within their respective stored procedure, and the result is persisted in the database. As you see in the slide, we are recording every activity of the user. This data is mostly append only, meaning that we might have hundreds of events that represent a single session. These events are processed within stored procedures, and only the final result is persisted on the database. We have separate schema for each game, and every game has 2 main tables, one for devices and other one for users. We have single record for each user, likewise a single record for each device. Also, each property of the user or device is also represented in a single column. So this design allows very fast access to the user state. And there is many-to-many relationship between user and device. So this is where SQL support gets very helpful. So let me sum up. Events are streamed from Kinesis to VoltDB. We use stored procedures for processing the events. We have many-to-many mappings between users and devices. Data is replicated with export-only tables for batch queries. And also, complex calculations that spread over long periods of time are made within the data warehouse and pushed to VoltDB regularly. And finally, I want to talk about the provisioning process of an existing game. How we move an existing game to VoltDB. When we decide to move an existing game, we have an automation system in place. In theory, we can replay all of these circle events and populate VoltDB. But that operation is very time consuming, as you can guess. It takes time to replay tens of billions of events and maybe more than 100 billions of events. Another problem is, with that is not all events come from single source. As I mentioned earlier, we continuously replicate MySQL databases to Kinesis. We use some of the data in MySQL, like the email address or some other in-game status of the user. It is hard to convert all of the database content into events just to populate VoltDB. What we do instead is we have SQL queries that run on our data warehouse to aggregate the data in the form of VoltDB data. We aggregate all the user data until a specific point in time. We also keep all the data in Kinesis that come after that chosen time. After aggregating the data, we import that data to VoltDB using CSV loader, which is a very fast way to import large amount of data to VoltDB. When the import finishes, we signal the Kinesis consumers to release all the events that come after that chosen time. It takes 3 to 5 hours, depending on the game. It may take more than that, depending on the game. And of course, if we have everything else ready, like the SQL queries for data warehouse. I should also add that this isn't just for new games. We use this automation system for new filters as well. Like say, we have a new filter called number of purchases that we didn't have before. And we tend to use this provisioning process to correctly populate all the historical data for that new filter. I think I've covered some of the important details regarding our services. That's all from me. I hope everything was clear for you, and let me know if you have any questions at the end of this webinar. And thank you, Dennis, and you can take it from here.
Awesome. Thank you very much, Sadr, for that great detail. It's always fascinating to me to hear how our great customers like Peak Games are using VoltDB to improve their users' experiences and their products and even their businesses. Peak Games' use of VoltDB is an excellent example of the power of VoltDB to power the real-time world. I recently did a webinar with Mike Gualtieri, Principal Analyst at Forrester Research, and the subject was the need for businesses to move from batch analytics to real-time analytics. And Peak Games is a wonderful example of that. They have hundreds of thousands of users playing their games at any point in time, and they're able to interact differently with each user in real time, perfectly shaping that user's gaming experience to make it as enjoyable and engrossing as possible, and thus keeping the user fully engaged. At VoltDB, we believe this shift is fundamental to the way businesses will operate and compete in the future. We believe that in the future, all businesses will compete on their ability to make decisions in the moment using fast data. Imagine playing a game that was not reacting to you individually, how you might get stuck at a challenge and get frustrated and eventually leave the game. That company wouldn't survive for very long when trying to compete with a real-time analytics expert company like Peak Games. Data is transforming business, and different types of data represent different opportunities. Fast data, data in motion, is different than big data, which is data at rest. Fast data applications analyze and make decisions on data as it is received in real time to have operational impact and benefit. Mike Gualtieri of Forrester reports that the value in fast data is perishable. It exists in that moment and can have exponentially more value than data at rest or older data. VoltDB is the only purpose-built database for fast data applications, and we're uniquely good at converting data into business value. The proof is in the pudding. Let's look at some actual customer results. We've already seen that Peak Games illustrates this point very well. They use the data warehouse for complex, long-running analytics and VoltDB for the actions in response to real-time per user events. Across multiple industries, data is leading to significant transformations. Companies like Uber, the ride-sharing service, and GE with their Predix industrial IoT platform are creating new businesses and new markets. Companies like Peak Games are transforming existing businesses and markets, disrupting them with data as well. Data and analytics are enabling a changing or fine-tuning of focus, from a focus on broad audiences to a new, tighter focus on individuals, with targeted marketing and services leveraging data that was previously either not available at all or not available in a meaningful context or not available fast enough for in-time action. Our CEO, Bruce Reading, calls this hyper-personalization. Studies have shown that companies that use data intelligently grow faster and are more profitable than their peers who don't. In those companies, data drives every decision, fuels every interaction, and powers every process. VoltDB is purpose-built for fast data on these key technical pillars. An in-memory, massively parallel architecture to take advantage of memory speed and the power of a distributed architecture. SQL, relational, abstracts a logical data model from the physical one, making application development and data manipulation simpler and easier, with support for Java and JSON to make it even more familiar to your developers. Data is always consistent, correct. ACID guarantees simplify application development by eliminating uncertainty and taking care of things like transactional isolation and data durability, so you don't have to worry about coding those into your application. Fast data ingest and export is built into VoltDB to simplify application development and system architecture, along with integration with key Hadoop components, making it much easier to create a fast and big data solution. Cloud ready, VoltDB is modern in its distributed data architecture, and it was designed from the ground up to be cloud ready, whether on Amazon, Google, Microsoft, or IBM SoftLayer. VoltDB's core technology pillars combine to provide a reliable platform for your mission-critical applications. VoltDB is the operational database that easily ingests fast data. It can analyze, transact, and make decisions in real time on fast data and export to permanent downstream data stores. While many parts of VoltDB are familiar, such as SQL, it being relational, and OLTP, the difference is that is being in-memory, scale-out, with fast data ingest and export, represent a game-changing combination that uniquely powers fast data applications. This diagram actually shows the user segmentation use case of Peak Games pretty well at a high level, where the fast is being handled by VoltDB and the long-running complex analytical queries that take long times to run are run on the MPP data warehouse, with the results being moved into VoltDB to add new segmentation actions or to refine existing actions. When we speak with our customers like Peak Games, we often hear that they chose VoltDB because it helps them to simplify their IT environments. A common scenario is that a customer is trying to create a fast data pipeline, so they use Kafka or Kinesis as an event stream message queue. They pick Storm for the stream processing and maybe add Trident or Cassandra for state management. Or maybe they go with the SMAC stack, adding even more components and complexity. But while the individual components, the separate Apache projects, are well tested and work well individually, Each use case is different, so the glue code between the components will likely be different as well. You may be able to find some pre-written glue code somewhere on GitHub for some of the pieces, but other parts you will need to write yourself. The implications of this are overwhelming for some companies. Instead of being a bank or a game company or a telco, you're suddenly a software developer and you're in DevOps. You need to be aware of all of the different glue code changes, the component changes, and keep up with a specialized skill set. You'll need to be able to write the code and maintain the code and test the code for all potential failure modes and support it going forward into production. The bottom line is you need to invest much more time, much more money in developing your data infrastructure. And it takes much longer to be productive with this to reach value, reach time to value using this application. When we visit customers, we often see development organizations taking this do-it-yourself approach, assembling 8, 12, 15, sometimes more components to create this fast data processing infrastructure. The challenge with the do-it-yourself approach is that the dev team ends up being their own DevOps or system integrator, integrating and testing the components, each with its own failure modes, which lengthens the time to value for the development investment. Oftentimes, open source components require you to find and hire highly specialized development talent. Sometimes that free software isn't very free after all. VoltDB was purpose-built for fast data and is an integrated whole, rigorously tested and QA'd, taking many fewer components than other solutions. Considering that each one of these Apache components can take a whole cluster of servers, using VoltDB typically reduces the number of servers significantly. We have even had some customers who have been able to eliminate or repurpose over 90% of the servers they were using for a particular application when they moved from a do-it-yourself approach to VoltDB. In the end, it's all about harnessing the power of analytics to make your business smarter. The significant step toward that goal is to be able to make more accurate and intelligent decisions quickly, more quickly than your competition. I spent a fair amount of my career in data warehousing, and we used to call these smart decisions actionable insights. The insights were the results of mining the historical data for patterns that could be used to help you change something about your business to improve the top line or the bottom line. The problem was that many companies and customers stopped there. They would build the complex, elaborate analytics platforms, the big data warehouses or data lakes. They'd go out and hire a bunch of data scientists to find the patterns in the data, but then they didn't know how to act on the insights. Sometimes because they just didn't have the ability, or they didn't know how, or maybe they did know how, but it took too long, and by the time they took their action, the actions were wrong because the data was stale or outdated. You got some great information from Sada about how Peak Games is using VoltDB in the gaming space. Here's some of the other industries and use cases where our customers are trying to do similar things to getting richer and more accurate actual insights and trying to act on them in real time. In the telco mobile area, we have customers using us for authorization. So if someone opens up a browser on a phone, how do you know whether you should allow them to connect to the internet or not, based on their budget, based on the amount of time they have left on their plan? In financial services, VoltDB is used in a sort of arbitrage type of application, where the financial services is holding a certain amount of stock and needs to get out of that stock profitably by the end of the day, with lots of different combinations possible for buying and selling. Ad tech, we see billing management as being a key use for VoltDB, and our customers agree with that. Good placement opportunities for a customer, but what happens if their ad budget is very low or close to zero? Should you buy that ad or not? Most eventually consistent systems won't be able to give you a definitive answer, and many of the times the ad tech company is left holding the bag on paying for that particular ad placement. And across verticals, we're seeing SLA management. Anytime there's a complex process with a short fixed time that needs to be completed in order to meet an SLA, that's being a key use case for Volt across industries. So if an SLA is not met, somebody's going to pay the price, and that's a very critical factor for many companies in many different verticals. What this means is that fast data in all of these industries and use cases becomes a competitive advantage. The fast data is there. It's up to you to harness it to improve your users' experiences, to improve user engagement and satisfaction, to make smarter business decisions, and to take actions on them faster, in real time, in response to event and user data coming at you in real time. It's a data-intensive world, and your business depends on data. There's nothing like VoltDB on the market. We're the only purpose-built database for fast data. VoltDB makes your business applications smarter and faster while simplifying your system architecture. VoltDB has the technology, know-how, and experience gained from helping hundreds of developers to help transform your business applications. We engage intensely with customers and commit to their long-term success. Each customer is assigned a customer success engineer to ensure that success. We welcome the opportunity to partner with you to help transform your business. And to wrap up, I encourage you to enter questions if you haven't already. You also have a white paper that you can download, the Developer's Guide to Streaming Data Applications. Or if you've heard enough already and want to try Volt yourself, we provide a link for you to download a free trial of the Enterprise Edition. And always feel free to email us at info@voltdb.com. I'd like to thank Sadar for joining us to so beautifully explain the use of analytics at Peak Games and how VoltDB is helping them to harness the power and extract the business value from their fast data. And we've already gotten quite a few questions. We may have time to fit a few more in, but we'll see how this goes. Serta, the first question goes to you. You use the same data model for VoltDB and for the data warehouse. How important is using SQL in your implementation?
Hello, Dennis. Thank you for the question. I think that's a great question. There are a couple of reasons why we require SQL. I think I can say that first of all, our data is relational. As I mentioned during the presentation, we have many-to-many relationship between users and devices. One user might use multiple devices, and likewise one device might be used multiple users. So this is a relational model, and most of the questions can be answered by simple SQL queries. When it comes to, for instance, NoSQL databases, most of the times you have to denormalize your data in order to answer some questions that can be easily answered by a relational model with SQL. So you can obtain related data from multiple tables using a single SQL statement, which is the case for our use cases. When it comes to NoSQL databases, you have to denormalize data most of the times, and it becomes harder to make changes which affects your agility in developing the services or the projects that you need to. Another reason is we generate SQL queries on the fly in our segmentation service. By replicating the data to another relational analytics database, we can answer analytical type of questions with the same SQL query that the system generates. So we don't have to write two different interfaces for two different databases. So SQL actually makes things much easier to operate and maintain. So it simplifies the architecture, as you mentioned previously. So the whole reason is to simplify the architecture. Also, SQL supported databases can be ACID compliant, which is the case for VoltDB. Having an ACID compliant database frees you from thinking transaction integrity and consistency. And I think I can add finally, everybody knows SQL, so that's also a very good reason to choose a SQL supported database.
great. Thank you very much, Siddhar. And just to add to that, we see basically the same thing from the VoltDB side. If it's starting out as structured data, it's really easier in the long run to keep it in a SQL database as opposed to trying to denormalize it out to a NoSQL database and figure out how to make up for data consistency, ACID compliance, and things like that. So especially with the structured data that we're working with, it's really the best way to handle it. Question came in for Volt. Does VoltDB provide extensibility or native support for geospatial? I think that's kind of two questions. I'll take a shot at the extensibility. If I don't get it right, comment back and let me know. As far as geospatial, yes, VoltDB has geospatial support. So we have the native understanding of points and lines and areas so that you can be able to figure out if a given point from a GIS perspective is within a certain area. So this comes into play very nicely for mobile applications where we can tell where a user is in relation to a store or a mall, for example. So you can tell when someone's walking by a store very closely, or maybe in the telco space, if a call is being dropped in a certain area, maybe that's a good indication to that telco that they need to put a new cell tower in that particular area to keep that customer happy. As far as extensibility goes, I mentioned the ability to do ingest and export, and that's a key requirement for us in fulfilling the needs of what we call a fast data pipeline. So just as Serta was talking about our ability to ingest from Kinesis, we can also ingest from Kafka or from many other places, RabbitMQ, anything that you have data streaming in, even with a comma delimited file. On the export side, likewise, we can export to lots of different targets, including Kafka, if you want to do that, Kinesis, or some established data warehouses like Vertica or Teradata, or any of the Hadoop distributions. So being a first-class citizen in that fast data pipeline is important to us, and we do that with minimal latency too. So you can stream data directly into VoltDB, pass it on to Kafka and the rest of your downstream applications or data management platforms, and have minimal delay in that process. So if that wasn't the extensibility you're talking about, please let me know. Another question came in, actually several questions related to hardware. So I'll kind of try to combine those all. For Serta, this was, what kind of hardware do you use to run VoltDB on? Do you have any special hardware requirements? And linked to that was how many nodes of VoltDB are you using? And to us was, what does a typical VoltDB deployment look like? So I'll take the first part and then I'll pass it over to Serta for his comment. A typical VoltDB deployment, really what you need to do is size based on the amount of memory. So we are an in-memory database, and we need to fit all of the data into memory. We have no problem with throughput. We get lots of throughput. We're talking about hundreds of thousands, if not millions of transactions per second on very small configurations. On a single laptop, you can do hundreds of thousands of transactions, queries per second. So you don't have to worry about that part. It's more the memory footprint that you're working with. And a very typical configuration for us is a 3-node cluster of commodity Intel servers with 256 gig of memory or smaller. It really depends on how much data you have there. And the 3 nodes is really to ensure redundancy within our cluster, so that we have a DR capability and replication capability. So you're not going to lose any kind of operation or any kind of data if you happen to lose a single node. Now, Serta, what kind of hardware are you using, and do you see any restrictions on hardware when you're running VoltDB?
I think that's also a great question. Our big data infrastructure runs completely on AWS. We run VoltDB cluster on EC2 instances, and never had problems regarding the underlying hardware. As you may know, the biggest problem about cloud services is the I/O throughput. So when it comes to services that require high I/O, like traditional databases, you require provisioned IOPS to satisfy high I/O requirements, which is quite costly on cloud services. Having an in-memory database obsoletes the high I/O requirements for this. At peak times, we see 100K writes per second, which is very hard to see for databases that run on disk, especially on cloud. Given that we don't use the most powerful instances on AWS, we are confident that we can scale as much as we want. Sometimes we do maintenance and keep all the events coming from Kinesis in Kinesis. And since the data we need to process grows as the time passes, it becomes millions of events to process. And whenever we open the gate from Kinesis, we can consume millions of events in just a matter of seconds. By running VoltDB on cloud, we don't have to think the hardware at all. It's a highly available and scalable database, which is resilient to hardware-related failures. As a side note, not all services are being used by all the games that we have. We have collection of services that, and they are provided to each game separately depending on the requirements of that game. We also tend to focus on the games that are most popular. Since we are processing the stream and aggregating the data on the fly, so we don't keep all the events that are generated by the users in VoltDB, but rather we aggregate them depending on the cases. The total data in VoltDB is quite small comparing to raw data that we have. We have hundreds of terabytes of data in our data warehouse, but we have just a couple of hundreds of gigabytes data in VoltDB. And we have 3 nodes running on AWS currently, and it hasn't been a problem since it's a very high throughput database. It's an in-memory database, so you don't have to deal with the disk I/O and so on. We will be, of course, scaling the cluster as we add more games and features, but that's what we are having right now.
Excellent. Thank you very much. And you bring up a good point that I had in one of my slides talking about the technology pillars. VoltDB is very happy to run on any cloud configuration, so you could certainly run it on premises on your own hardware, or you can run it in Amazon, you can run it in Google, you can run it on IBM SoftLayer. It really doesn't matter. We're happy to work with you, any customers, in deploying our software into the cloud. Last question that came in here, can you compare VoltDB with Elasticsearch? And Elasticsearch is actually one of our export frameworks. So we worked very well with Elasticsearch, and I think that the link here is Sada mentioned a Lucene-based tool, and they probably were thinking about Elasticsearch. So we see Elasticsearch on the other end of the spectrum for us. So we're dealing with the fast data, and the Elasticsearch is great with the big data. So those terabytes of data out there that you need to do some kind of lookup for probably will run better on that system out there. And just like Sada said, we're dealing with, typically since we're a transactional system, we're dealing with smaller amounts of data. You really don't want to put tens or hundreds of terabytes of data into VoltDB, although we have customers who do put 5, 10, 15, 20 terabytes, and it works just fine. It really depends on what their use case is and how fast they need reaction to that data. For historical big hundreds of terabytes to petabytes of data, that's much better off in a data warehouse or your data lake where you can run those nice, complex, long-running queries on them there. VoltDB is really for being able to run those really fast transactions based on context. And the context is that historical data. So Elasticsearch we'll be happy to work with on the back-end system there. We have a fast export to that if you happen to use that. And just a thanks to Bob for his comment about a future webinar about hearing about more OLTP applications that decide to go with VoltDB instead of a traditional database. It's a very popular topic for our customers. people who are frustrated with working with Oracle or MySQL or any of the other more traditional databases. We are a transactional database, so we work very well in the operational space, and we'll be happy to pull together something for you. So that's all the time we have. I appreciate your attendance on this webinar. Serdar, thank you very much for joining us from Turkey and providing us with all that great information.
Thank you, Dennis. Thank you, everyone who is watching.
And we'll have another webinar coming up for VoltDB August 18th. We'll be doing something with HPE Vertica specific to the IoT space. So if you have any interest in learning how transactional databases can work with big data databases for IoT applications, definitely tune in. And thanks again for attending.